So for this video, I'm just going to go over some of the questions on the review, mainly the questions that deal with intersecting planes. So I ask you things about what's collinear, what's coplanar, what two lines are skew, because we hadn't really talked about skew yet. So that's what this whole little video is. And let me just do one more thing. All right, so go ahead and copy this figure, pause the video, copy it. Now go ahead and copy the rest of the questions. So there's a couple more. Once you have all these copied, then we can start. So let me move my little camera back up here. All right. So let's look at this here. So the first question, and again, these are just like the review. It says name two collinear points. Remember, collinear points are 2 points on the same line. Now, in this figure right here, I have several options. I could say, let's see. So 2 points on the same line. So E and H. So I could say E and H. I could say A and B. I could say D and C. Because see, D and C, it's along the same line. Is there anything else? Okay, G and F. That's a line, so G and F. So there's multiple things that you could say. One thing that I couldn't say is something like D and E. Okay, D and E, those are not collinear. All right, there's no line that actually goes through them. Now you can construct a line if you wanted to, but the way it's labeled, there's no line through D and E. So I would not choose that. Collinear means just pick 2 points along a line that's already drawn. The next one says name 3 coplanar points. Coplanar means that they are in the same plane. And once again, I have several options here. I could, because notice, this is a plane. We call this plane S. This is a plane. We call it plane R. So there are many different points that I could choose here. I could do E, H, and A. So E, H, A. I could choose A, G, and B. Those are still on the plane R. So AGB. And let's look at the other plane. See if we can find some on this plane, plane S. So three coplanar points on plane S. So I could do F, C, and D. And there's a few more that you could do, but hopefully you get the idea. Now let's see here. Let's move on to the next question. It says name a line coplanar to plane R. Coplanar to plane R. So I need a line that is in the same plane as plane R. So coplanar to plane R means I need a line that is in R. So there's 2 different lines that I see right here. Actually 3. I could have AB. So let me write that down. So I could have line AB. Again, if you draw a line, you have the 2 little arrows. I could have EH. EH is in that plane. That's in plane R. What else is in plane R? G and F. Because G and F is the intersection of these 2 planes. Remember, when 2 planes intersect, they form a line. Right? That's actually a postulate. So GF is a line that's formed when they intersect. So GF is a line that's coplanar to both R and to both S. So GF is coplanar to plane R. It is also coplanar to plane S. All right, let's move on to the next one. Name the line that forms the intersection of planes R and S. So this is plane R. This is plane S. When these two planes intersect, they form a line. That line would be GF. And if you remember your postulates, the intersection of two planes forms one and only one line. And finally, this is something we have not gone over. Name a line skew to DC. So a skew line, it's two lines that do not intersect and they lie in different planes. Now, you know parallel lines do not intersect. If I have parallel, suppose I have two parallel lines. They do not intersect. They're in the same plane. They do not intersect, okay? Those are parallel. Skew means that they are not in the same plane. So this paper right here is a plane. Suppose I have another line sticking up out of the paper. Pretend my marker is another line. This line is skew. This line will never touch either one of these lines. It will never touch them, and it is not in the same plane. Okay, this plane is going this way. This plane is going this way. That's what skew means. Now, if I change my line like this, all of a sudden they're not skew because I can create a plane that actually goes through them. So let's look at the figure about skew. In this case, the two skew lines, let's see, skew to DC. So this is DC. This is DC. Well, I can't say GF for two reasons. First of all, eventually they will intersect. If I keep on drawing them, these two will intersect. But also notice they're in the same plane. They can't be in the same plane. So skew to DC would be something like AB, because notice AB will not intersect DC. They are in two different planes. So I could say AB. I'm sure you can see that. So I could say AB. And there's another one that's skew too. Look at this. EH. EH is in this plane. It's going this way. DC, it's going completely different in a different plane. So EH is also skew to DC. So make sure you have these notes for the review because the review asks questions that are just like this. And just one more thing that I want to talk about before I end this video is the biconditional. So let me just kind of move this little camera over here. So biconditional. We also call this if and only if, IFF, if and only if. That means if P implies Q, then Q implies P. So both of these conditional statements have to be true. So moving along just real quickly. Okay, how about this? If the Spurs win, then I have a good day. Okay, so if the Spurs win, then I have a good day. That's my statement. Okay, this is my P. If the Spurs win, that's P. The rest of this, I have a good day, that's my Q. So a biconditional statement means that I can switch these around. I can take the converse. Remember, the converse is when you switch it around and you say Q implies P. I switch these two. That's the converse. So if I took the converse, it would say, if I have a good day, so if I have a good day, then the Spurs won. So on the test, you're going to be asked, is a biconditional statement true or false? When I say is a biconditional true or false, is the conditional and the converse both true? So let's see if this biconditional is actually true. if I wrote this as biconditional, I'd say if the Spurs win, or actually I would say the Spurs win if and only if I have a good day. And let me write that down. Okay, so biconditional. I would say, so again, this is the biconditional version. I would say the Spurs win if and only if I have a good day. If and only if I have a good day. Okay, so biconditional would be the Spurs win if and only if I have a good day. So now, is this true or false? Is this really a biconditional? So let's look at this. Now, if the Spurs win, then yes, I have a good day because I'm a Spurs fan. I love Spurs. If they win, I have a good day. But let's look at it the other way around. Look at the converse. If I have a good day, then the Spurs win. Is that always true? Well, not necessarily, because I've had a lot of good days this summer, and the Spurs don't even play this summer. So they didn't win those days, but I still had a good day. So that would make it false. This biconditional is false. Why? Because I have good days when the Spurs don't play. When the Spurs don't play. All right, that's why it's false. That's my reasoning. My reasoning for saying this biconditional is false is that I have good days when the Spurs don't play. Because biconditional means I have to go both ways. I can easily go this way. Okay, I can do P implies Q. If the Spurs win, then I have a good day. But when I look at the converse, if I have a good day, then the Spurs won. That's when it breaks down because I can have good days when the Spurs don't even win. All right, so that's the biconditional recap. So just remember the review, get it done before the test because the day of the test, I will go ahead and I will post the answers to review to help you guys out. All right.